Okay, question 4.1 wants us to find a binomial expansion of this expression here. So there's a few ways that you might have been taught to do this. We need the coefficients of each term, which can be either found using NCR or Pascal's triangle. Pascal's triangle is much quicker, which comes from adding the consecutive terms in the row above together to give you the number underneath. So 1, 5, 10, 10, 5, 1. Or these numbers can also be generated by doing 5C0, 5C1, 5C2, 3, 4 and 5. So because I've got the numbers here, I'm just going to use the numbers straight away, but you might have calculated 5C1 and 5C2, etc. as we went. So we start off with the first term here and raise it to the biggest power and give the other term, which is x, the power of 0. And then we're going to decrease the powers for 2 and increase the powers for x until they've been reversed, and so we've got x to the power of 5 at the end. So first coefficient is 1, so we're going to get 1 times 2 to the power of 5 times x to the power of 0, which is just 1, so just 2 to the power of 5. We're then going to get 5 lots using the 5C1 value of 2 to the power of 4 and also x to the power of 1. Next term is going to be 10 times 2 to the power of 3 times x squared. Next term is going to be 10 times 2 squared, x times x cubed. Then we're going to have 5 times 2 to the power of 1 times x to the 4, and then we're going to have one lot of x to the power of 5 with the 2 to the power of 0, which is just 1. I always write it longhand first and then simplify the terms later, because you'll get method marks for this. So 2 to the power of 5 is 32. 2 to the power of 4 is 16, so 16 times 5 is 80, so we've got 80x. We've then got 10 times 2 cubed, 2 cubed is 8, so that's 80 as well, 80x squared. We've then got 10 times 2 squared, which is 4, so 40x cubed. We've got 10x to the power of 4, and we've got x to the power of 5.